understand is your basic AC wiring in your house, how it really works. So if we bring up the first slide here under AC systems, open this one. Yeah. Okay, this is a general layout of how your house is set up. You have your higher voltage that goes to your big transformers on your poles. Those transformers usually service about 6 houses, and they'll have lines coming out to them. There are 3 wires that come into the house. One they call the neutral, which is the center tap of the transformer, and then you have 2 hots. And if you remember transformers, when you have a center tap, you have 1 voltage from the neutral to the hot on this side, and 1 voltage from neutral to hot on this side, and the entire voltages from hot to hot. So what happens is the system that comes out of your transformer is 220 volts. And you'll need that for your stoves and air conditioners and some devices that want 220 volts. And if you start getting into using power amplifiers, which we'll talk about later, some of them run on 220 volts. So when it gets to your panel, both of these lines are hot. So they have breakers. There are 2 actual breakers in your system. They don't just break one wire. They got to break them both because these are both hot. And typically they'll wire them to each side of your panel. So now each one of these lines, when measured between this neutral, which is the last wire that comes in, it goes to a common electrical ground. The voltage between here to here and here to here is about 120 volts, 115, they're in that range. And that's what you're getting at your plugs and your lights and so on and so forth. Now, if you plug in a linear, or you plug in your stove and your dryer, then you're going to use both sides. So they'll have a wire coming from one side of your panel, the other side of the panel, and they will go to a special plug, which you're probably familiar with and have seen on the back of stoves and so on. And that's 220 volts. And they're taking the voltage across here. So that's, and some linears, when you need to have these plugs put in, that's what you're going to have to do. You're going to have to understand that. But most of the time, you're just going to be dealing with your average outlets. So your average outlet it either comes from one side of the hot line to the ground. And typically, you'll notice something rather interesting here, that you have a hot wire that comes off one side of the panel, and then you have your neutral white wire, and it goes to your AC ground. But you also notice your ground wire goes same place. So both of these wires are essentially at the same potential. A lot of people don't realize that, but they are. So why have the third wire? Well, the reason is because if something happens and this hot wire shorts to the case of your equipment or something along that line, you could be electrocuted because it now becomes hot. With this third wire, it's a dead short. So it's going to signal the fuse right away, and it's going to pop it. That's why that wire is there. It's the same potential as your white wire, but in order to get to this wire in the circuit, it has to go through a load, which probably won't blow the fuse, but if this shorts to the case, it's going to be hot. And you touch it, you're going to get zapped. So this, fastened to the case of modern radio receivers and other devices, will prevent that from happening. As soon as that short occurs, fuse blows, and you notice something wrong. So you find out what it is. Now, those of you that decide to get a little bit vintage, and a lot of people do, they start collecting older radio receivers and stuff from the war ages and so on. These radios did not have that third prong on the plug. They had a metal chassis also. So some of them actually put a voltage on the chassis. In some cases it's a very small amount when it's working properly, but it has the potential, if the short is in the right place, to put some very lethal voltages on those cases. So be aware, if you're using a device with a two-prong plug, watch out for this. In most cases, you want to rewire it for 3 if you can. because there's a very dangerous voltage on them. Some of the old tube sets require B plus voltages of 2, 3, 4, 5, 6, 800 volts. That 800 volts DC gets onto that chassis and it'll kill you. So be very careful with this stuff. If you're going to play around with it, make sure you know what you're doing. Take a voltmeter, check it. Make sure there's no voltage on that chassis. And if you're good at stuff or you have a friend who can do it, it's a good idea to add that third prong. Put a new plug on it. So we talked about ground wires and chassis and so on and so forth, and the importance of this ground wire. We talked about vintage radios and warnings about some of the older, anything with a metal case, be careful. Make sure they're grounded.
Did they have any with plastic cases back then, or they were pretty well
Yes,
metal?
some of them had plastic cases, but they had screws on the surface of the plastic cases and metal knobs. And any one of those possible pieces could be common to the chassis inside, and there's still a possibility of getting zapped by just touching a screw on the case. So just be aware of it. I'm not trying to scare you away from them, I'm just trying to make you aware. They can be operated quite safely, just be aware. Now all the stuff that comes into North America, more or less, anything that's proved with CSA on it, or European standards, even better. The European standards are even better than us. You see something with an EU standard on it, it's better than CSA, or underwriter laboratories. Any of those, they're safe. They're safely designed. They have all the grounds. They're pretty safe, nicely designed equipment. Some of the stuff that sneaks in from China, you be the judge. You may also run into, you may purchase equipment from other hams, some of which has been built. Now, as a basic operator, you're not supposed to operate anything that's been modified, that's a transmitter. But that still means there's receivers, there's power supplies, there's all kinds of little devices that you can pick up from somebody that you need to be aware, make sure that it's safe before you start playing with it. This guy may have used 2 wires on it. You may not have put a third prong on it. You don't know. So it's a good idea to be cautious. Watch for that. Now, again, as basic, you're not really supposed to play with this stuff, but basic operators are allowed to do certain things. Like a basic operator is allowed to do a repair on his equipment as long as he replaces the exact same value of component for the other. No modifications. Okay? You're allowed to do that. You can build kits that are commercially designed, but you can't make the modifications. So in the case of when you're playing around with equipment that's had power on it, or even if you don't even know if it's had power on it, you're going to play around with something inside, discharge the capacitors. Some of those capacitors can hold a charge for weeks, and they will give you a good poke. So the standard procedure whenever you take something apart you're going to work on that has big capacitors in it is to take a clip lead or something, clip it to the chassis of the device, and just touch all the capacitor leads for a second. You'll probably just see a little spark here, a little spark there, a little spark here. Better a spark there than into you. So once that's done, it's relatively safe to work on the equipment as long as you're not plugging it in again. But those capacitors will hold a charge for a long time. And also, the old TV sets, those things are lethal. Okay? A lot of people don't understand that even after you discharge all the capacitors in these old TVs, the biggest capacitor of all is the picture tube. That thing can hold lethal voltages for years. So that also needs to be discharged. Just a point of view to keep you in mind. Okay. Grounding, Grapeford. Okay. Antennas. Every now and then you hear about somebody that gets killed trying to put up an antenna. There's a couple things you need to be aware of. Respect power lines. If you're going to put an antenna up, make sure you know where your power lines are. If there's any doubt that you might possibly brush it or get near it, don't. Okay, just find another place for your antenna, because it's too late when they're chiseling out the stone with your name on it. Okay? And Murphy's Law. Hams should really believe in Murphy's Law. And everybody knows what Murphy's Law is, right? Anything that can happen, will. So if you guide yourself by that principle, you can probably stay alive and have a happy hamdom. Good. Respect electricity in all forms. And if you're going to climb towers, make sure you have the proper safety equipment. You know, strap yourself in. If you're not sure how to do it, you don't have the right equipment, ask around the ham community. There's lots of us that have the right equipment. There's lots of us that have the expertise. We can train you on this or help you out. Don't go on your own unless you really know what you're doing. And I still wouldn't do it. You know, pizza and beer can buy you all the help you need for an afternoon. It's like barn raising. Hams love to raise antennas.
They had a case up north years ago where there was 4 guys and they went to move a tower.
Yeah.
And they didn't want to assemble it, so they tried to move it intact.
Uh-huh.
2 of them were sort of pushing and 2 were pulling, and it hit the high voltage line. And the guys were pushing into it, they stayed there, they died. And the 2 that were pulling it the other way, 3 of them back.
Yeah.
But they survived, but the other 2 did. I'm not sure what the voltage was, 4400, 14.4.
Well, I don't know if this is covered so far, but does anyone know how much current it takes to kill you?
0.01 of that.
Yeah, 0.01 of an amp. That's 10 milliamperes. That's less than comes out of an AC adapter. Now that's based on going right across your heart muscle. So, you know, usually to do that, you need a fair amount of voltage to push it. But just understand, it doesn't take a lot of current to kill you. If you make the right connection at the right time, it'll stop your heart. I'm going to make you aware of one other little surprise that some people don't consider. High voltage lines. They are running high current. What happens when you run current through an inductor? Everybody knows this, right? You get what? You get a magnetic field. Yes. And what happens if you bring another metal object into that magnetic field? It induces a current in that metal object, right? Well, here's a 500,000 volt Kevlar lined big power what do you call it? What do you call those things? Transmission lines out somebody's farm, say. They decide they're going to put up an antenna, maybe 60, 70 feet away, 20-foot tower. Not going to come near it, no problem. Well, be aware that it's possible that that magnetic field can actually induce a current into your coax cable through your antenna, burn out your radios, and possibly give you a nasty shock when you grab hold of it. And there are ways to deal with this. We have to get proper station grounds. We'll deal with this. But if you neglect the station ground and you've got a magnetic field, you're looking for trouble. I had a friend years ago, back in the CD days, he couldn't keep a radio in his house. Fire it up, receiver's gone. Get another radio, hook it up, receiver gone. Nobody could figure out what the problem was. So I'm looking around, and I see these power lines in the backyard, and I see this ground plane about 5-6 feet away from them. Interesting. So I take a voltmeter and I measure across the center conductor, the coax, and the braid, 90 volts AC. Guess what's killing his nice little field effect transistors in his front end? Pop, gone. So we had to fix that. So understand, remember, the stuff we're teaching you, it actually does work. It's good to keep in mind these little things. Your transmitter. When you're operating your transmitter and you're feeding power into that antenna, there's current flowing there. There's voltage present. Depending on the type of antenna, the voltage is higher at the feed point and lower at the ends of the antenna, or there are different points where the voltage is higher, current is higher. It depends on the construction of the antenna. Understand that if a person was to grab hold of an antenna with a reasonable amount of power in it, they could receive very severe RF burns. So I strongly suggest you putting up an antenna, keep it out of the reach of children, pets, and other people. Get it up there where they don't even have a ladder high enough to support themselves to go up and grab it and swing on it. Yeah? Keep it out of there, because it can cause problems. Respect your equipment. Understand beam antennas. A beam antenna can focus the energy and thereby concentrate it in one particular area. It is not a good idea to set up a beam antenna right next to your neighbor and point it into his front room. Put it up above the house. Put it away if possible. You're courting disaster. Now, as far as antenna systems, from a department standpoint, most amateur equipment is exempted from having to go through fancier tower approvals and so on. However, once you get past a certain height, which is 18 meters, then you're going to need a consultation. And that can vary depending on where you are. There may also be a need for some kind of consultation if you're in a aesthetically protected area, and there's other little factors. Yes?
Is that 18 meters off the ground, or even if you attach it to your house with a pole?
Ah, good point. Okay, let me explain it this way. 18 meters from the ground to the tip of your highest antenna tip, your antenna. That's the ruling. After that, you need to go through whatever procedure is required for where you are. Now, there's a little loophole that you can make advantage of later. You are allowed to increase that height by 1/3 once after a year. Only once. So if you're planning, say, a beam this year, and you want to add a vertical the next year, you can do it. But technically you shouldn't do it right away, or you could get clipped, but of course they probably will not care about a piece of wire sticking in the air, but you get my drift. Or if you want to raise it 10 feet in the first year. You only do it once, and it's still exempt. Now, for the further information on that, we can close this one. Under, should be a subdirectory. Where is it? Should be one called Documents.
Grammar library.
Try RF interference. No, RF interference. Right here. Under Documents. Okay, this one right here. Second one down. You'll find this on our website. Second one, that's it. Yeah, don't click that. CPC 2-2.03. This is the document and that will explain to you whether or not you're exempt. And there's a section under section 7 or 5. Where is it now? 7.2. Radio frequency, proximity. Where is it now? Resolution. Exclusions, number 6. Talks about what your exclusions would be, and there's a section about amateur radio antennas if they're under such and such and so on. A lot of there were some changes recently to this, but fortunately for us, they're aimed at wireless provider systems, so they don't affect amateurs. They tightened it up for commercial providers, but they left us alone, which is good. So this is the document. If you really want to know what's going on, this is the document. It's available on our website, CPC-2-0-73. And the name is, scroll it back up. Should show up in the top of each one. There it is, right there. In the top of any one of these pages. No, further up. Right there. Radio communication and broadcasting antenna systems. That's the Bible when it comes to whether or not you're exempt. Okay, safety covered. What's code 6? Safety code 6. That's a document that also is available on Health Canada site, and what they have set a limit of radiation that is considered safe for the public. So amateurs are required to adhere to this, and you usually will not have a problem with this as long as you're not operating excessive amounts of power. Once you start operating excessive amounts of power and you're getting close to your neighbor's window and stuff like this, there is a calculation, simple calculation that you can perform to determine whether there's a problem or not. But in most cases, it's not going to be a concern. You also need to be aware that the public is very uneducated in this area. There's a lot of scaremongering going around, which will not go well for you if there's a situation where someone comes up and says, well, you're putting radiation into my head, and so on and so forth. So whenever you're talking to the general public, don't let them use the term radiation. Radiation scares them. It's radio signals.
You can always just refer to their cell phone and put to their head every day.
Yes, well, that's out for debate too. They'll talk long about that. The safety code 6 is based on a scientific study of what it takes to raise the temperature of human flesh from being exposed to a non-ionizing radiation at certain frequencies. And the guidelines are at least 50% safety zone. So, in my experience with my department work and so on, it takes about a 25 to 30,000 watt TV transmitter or FM broadcast transmitter to generate safety code 6 levels. And you would only see them if you climbed up the tower and were about 15 feet away from the radiator, or dangled yourself in front of the radiator up to about 50 feet, which isn't going to happen. So typically it doesn't come near where you're going to get affected. Okay. In the process of doing a lot of things, you're going to probably start using a device called a soldering iron. Well, soldering irons are, they're good and safe, and I recommend that you always do get one that has a 3-prong plug on it. There's a few of these other ones around with 2 prongs, and for the same reasons we talked about, not a good idea. So what you want is an insulated 3-prong plug on a soldering iron, and typically you want about 30-35 watts minimum to do most work. And when you plug these things in, do not forget they are hot. And they take time to cool. I think we've covered safety. Any questions? No?
I have a same question I think I asked last year. I'm sorry I forgot the answer. So, if you did your own wiring, which you're not supposed to do anyway, you have to get the white on the right side and the black on. You can't mix them up. And what's the problem with mixing the wires up? I mean, they're marked on the receptacle, right?
Yeah.
And you're supposed to put one in this place and one in that. And if you put them in the wrong place, why would that cause them?
Depending on the device, it may put lethal voltages on the case of your device. Most electronic devices just won't function with the reversed plug, although it is AC. So unless by the time it's converted to DC, it shouldn't be a problem. But some devices don't like the reverse, and in some cases, as we said, the ground and the white are the same potential. You reverse those wires, you've now made your entire grounding system for your whole house live.
Oh, okay. I see.
hot and then neutral. Okay, so.
Yeah.
Hot on our neutral.
And you've just you've just set up a situation where grounded chassis that are relying on that third plug
Yeah.
are now hot. So every device you have with a metal case is potentially lethal. So very important that you get that right. And in order to assist that, all of your standard AC outlets have a dark colored screw and a light colored screw. Your light colored screw is your neutral, always.
It's always on the side of where the ground is.
Yeah. And your dark colored screw is your hot. So, and again, if you don't know what you're doing, get someone who does. These voltages are deadly.
One of those little testers that tell you the polarity.
Yes.
That's right.
Yes.
They're handy if you buy a new house, you go around and check to make
Yeah.
sure, you know.
But I'm telling you, if you're the type of person that needs to plug one of those in to know it's right, you shouldn't be doing the wiring.
I was thinking more if you bought a house and you weren't sure.
Yes, that would be a good test. Yeah. Because I don't trust made in China devices with my life. If you're going to play with AC and your house wiring, know what you're doing. Or don't do it. Get someone else. Trade favors. Hams do that all the time.
Call top line. Call top line.
Yeah, top line. Well, they're expensive, but they are good. They did my garage.
Very good phase four. Very good phase four.
Phase 4 is good too.
He works for Phase 4.
Yeah. Phase 4 and top line, I think they have really good reputation, and the inspectors don't even inspect the work. They go, did they do it? Yeah, sign it.
Inspectors never even showed up when they did my garage.
No, they didn't come from mine
They
either.
didn't come.
I called and said I left the key and everything for them, and they came in there, and the guy said, "Boy, he signed it off." He said, "Top line did it."
Yeah.
It's okay.
That's because they got the pre-approval from the
Yeah.
contractor pre-approval.
Yeah. 1 out of every 10 jobs with someone's stuff. Okay, if you have that.
Not to do a commercial for Grandinetti, but he did my garage, and every time it was time for an inspector, the inspector said, "Grandinetti did it? I'm not wasting my time to inspect it."
He works for Top Line? He works for Top
No,
Line?
no, he's a. I brought in Grandinetti. I brought in Top Line to do my garage because I didn't want any problems with insurance.
Oh, I see.
You know, they're not going to come back on me. I've got all the documentation.
Yeah.
Okay, so anyway, back on to what we're doing here. No more questions about electrical safety.
Most of these guys are electricians.
Are they really?
Yeah.
Oh, well, they're gonna tell me if I messed up then. Yeah. Okay, so should I continue, or we take a break and start radio interference, or what? do you
Sure,
think?
whatever you want to do.
Let's do a break,
Okay.
and then we'll get on to radio frequency interference, the fun stuff.
1, 2, 3, 4, 5, 6, 7, 8.